Hello and welcome back to the Renewables podcast. We are here again with another exciting topic. But before we get into it, I just want to say if you haven't already, don't forget to subscribe to the channel. And if you head over onto Spotify, you can get a week ahead on the show for next week's episode as well. There's only a low-cost charge there. It does help us with the podcast. So please do go and look at that. Before we dive in right to the topic, how are you doing, Sam?
I'm all right. We're doing a couple of episodes today, aren't we? So it's been nice to get these in just before Christmas. Very much looking forward to having a break. Like we mentioned, the last one we just recorded, I've got tomorrow, and then I'll be hitting those ski slopes. I cannot wait. I don't know if other people are like this, but I don't really get excited about holidays because I feel like the pressure of leaving the business and the stress of that can sometimes mean that I don't really enjoy leaving it. I much prefer to actually be there and be able to tackle anything. But Jess, my wife, has said, this is the only holiday I've ever seen you excited to go on. And that includes honeymoon and all these other things. I'm thinking, well, you're probably right, actually. So I'm really excited to go and have a bit of time, just me, friends, Jess, and be kid-free for it as well. But yeah, a bit stressful on the lead up to it, but very much looking forward to getting to the ski break, but also the Christmas break. But how are you feeling about it all? How's it all going?
Yeah, I'm in similar feelings, but a week longer than you when I'm not going skiing. So I'm very much looking forward to shutting off for a couple of weeks. And it's not a hard deadline in the sense of being away from a holiday, but we do want to be down tools, not in emails so much, and trying to have at least a week or so out of the business, enjoying Christmas with friends and family. But we'll see if that actually comes to fruition. You know what it's like.
Yeah.
That's our aim. And it's been a busy one this week as well. We've had a few interesting projects going off. Same, I imagine, as yourself, and lots of other installers out there. We're just trying to wrap up as much as we can and get as much money in pre our year end. Our year end's end of December. Just trying to make the books look as nice as possible on that front and set ourselves up for a good, strong start to the new year. This episode, though, I think we're going to go a bit technical on this one. We're going to try to anyway in our own style. And it's a topic that's been discussed a few times. I think we've mentioned bits and pieces around this before, and it kind of sits around the world of DC, so isolation points, surge protection, and fire protection as well. We've both had an experience of that we can maybe talk about in this episode from a Zoom call we were on earlier this week, or was it last week now? I forget.
This week.
This week, yeah. So we can maybe reference into that. But I think it's something as installers that we need to think about, because manufacturers are telling us one set of things and their awarding bodies or CPS providers telling us another set, and then we've maybe got kind of the muddy waters around everything else, and making sense of that is hard sometimes.
Oh, it's an absolute nightmare. We've seen that with the PAS 63100 document, and like myself, I've really tried to take that on board. But the reality is every single one of our installations will not be PAS compliant because the equipment just simply isn't PAS compliant for the best part. But I think whenever we're looking at this sort of thing, we have to remember we're using our technical judgment as installers, as competent people, to give our end users, our installations, the most chance of longevity, but most importantly, safety. And I think when you come from it from a point of remembering that is your responsibility as a competent person, you start to look past some of the noise around cost cutting and start to look at, well, what is going to be best for this installation and this customer? And the reality is that a lot of the things that get spoken about that maybe aren't required are usually being spoken about because of the cost implications of that. Not always, I think I might get this reference wrong, but is it like an R62 document or something? But it's like more of an insurance document where they're talking about the whole DC isolation side of things maybe not being required anymore or not being advised, and I think that's because they've found that it's more of a point of failure on some of their insurance claims. Or I might be getting some of the details wrong. Unfortunately, I've not got that in front of me. So, please feel free to correct me, either Mark or anyone in the comments. But I think it does not surprise me one bit that some of these DC isolators have failed, because some of the states that I've seen these DC isolators in, there is absolutely no doubt that the ones I've seen will probably fail at some point. And you just have to hope that they fail in a way that is, they fail safe rather than fail live and start arcing. But yeah, what's your take on some of that?
I mean, you're right from what I can understand as well with that document and the insurance research. But I think that's when we're looking at like cause and symptom and really getting into the nitty gritty of why those things are happening. And you're right, some of the DC isolators to begin with, maybe we had even DC isolators to start with, they might have looked like a DC isolator, had DC isolator written on it, but there's lots of them that were just repackaged AC isolators in their first iteration, and installers wouldn't know any better. And the same in the way that they have actually been installed. So they've maybe not been made off correctly with ferruled ends on the fine stranded cabling. They might not have had cable support and strain relief as the wiring's entering into them, or they've been installed outdoors with top entry, or had the backs of them drilled out to allow fixing holes. And there's all these things which is going to play a part for that item to fail. But for me, that doesn't mean it's not necessary in the wiring system. I think it does provide an important function that we'll maybe get to later in our chat. So I think sometimes the knee-jerk reaction is, well, if that's the issue, let's get rid of that. But I think it's what usually happens is the problem just moves somewhere else. You've not solved it. You've just moved it either down the road in time, waiting for something else to go wrong in a year or to a different part of the installed kit. Could be at the MC4 connectors, for example, or at the inverter itself. You know, you've not solved or changed that core issue. And I think from the conversation we had on that call earlier this week, when you're speaking to people from the fire service who are dealing with the consequences of when all of that does go wrong, that should be the founding driver for me, that we're trying to stop that. We're trying to stop firefighters having to put PV fires out, stop seeing in the news all the, what I think is now starting to border on scaremongering, where consumers might get put off altogether from this technology because they believe it's unsafe, when much of the problems that are there are nothing to do with the kit or the installers who are doing this diligently. It sits in a place beyond that. And if we're really serious about sorting a lot of that out, we need to be honest of that and do something about it, rather than just have blanket statements of remove DC isolators, because for me that fixes nothing.
Yeah, I think you're right. I think, you know, not having a DC isolator is one of those things that, yes, it'll save you money. Yes, you know, both on the materials and on the time. Yes, it'll save you space, because there's physically not 1, 2, 3, 4 isolators sat there. But what do you lose by not having that? And you lose the ability to safely isolate those cables. You lose the ability to test at a terminal rather than at an MC4 connector, and potentially wear that MC4 connector out, or, you know, expecting a customer to be able to isolate the string by, you know, turning off the isolator on the inverter and then pulling the MC4s out. What damage are they going to do to those? Are they going to protect, you know, they're still going to be removing and handling a live end. So for me, it just seems like absolute nonsense to suddenly decide we're going to introduce this idea of just getting rid of something because there has been a failure on it. There's going to be a failure no matter if you're the most diligent installer ever or if you're the biggest cowboy ever. You're still going to have failure on equipment. That's just like nature. You're always going to have that. So I think we've got to work out what are the wins that we can have with very minimal cost impact, but instead of having all these kind of hairy-fairy ideas of maybe we should do this and we advise you to do that, have some solid guidelines. Solar is established enough now for us to start being really serious about this is now what is the minimum expected. And MCS have, you know, in their guidance, they have a lot of this written down, but it can sometimes be a little bit hard to find, or they, you know, people maybe struggle to digest it all. And I think there needs to be more focus on what is the actual standard, what should people be doing. You know, we've spoken about before on, God, I think it was this podcast we've just done to, about the PAS document. You know, what should we be installing this to? And I appreciate we're in an area that is very much a new and ever-changing area, but you know, the fact of installing a DC isolator doesn't change whether or not it's a brand new inverter that's come out, or if it's, you know, an inverter that you've gone to from a feeding from the beginning of the feeding tariff, that isolator still provides you with a lot of value. And I know that call was really eye-opening to hear from the firefighter side of things, what they're finding in terms of when they can determine the cause of a fire, what they're finding that is the cause of it. And he was leaning a lot on the MC4s, wasn't he, as well?
Yeah, and inverters themselves and the panels themselves as well. It's not restricted to just any one component, I would say, overall. I think sometimes you can take an element of data and read too much into it. It's still quite a small pool of data fundamentally, and there isn't a vast back catalogue to reference it against either. So you get these kind of headline statements that PV fires are up 30% on last year or whatever, but the scope of research is bigger, so they're asking more people feeding into it is larger, and the kit is another year older. And as you've referenced on chats before, another year generally without any maintenance. That's another element that we need to really look at, again, if we're serious about solving these problems, is the maintenance side. And the DC isolation is a great way to allow that maintenance to be done safely. I mean, you could be going back to an inverter that's 10 years old, and them MC4s might never have been pulled once in that time, and they've been there carrying lots of current, lots of voltage. They could have been out in the elements, all rains, winds, temperatures. If they're up in a loft, the cycling of all of that, the fauna and the fauna, and asking an electrician to go to work around those, even if the DC breaker's switched off, I don't think is a safe system of work to leave in place for the next person. That's one of the principles I have with DC isolators, because the MC4s are quite close to each other on the inverter. It's not beyond the realms of possible if the person who first made them off didn't use a crimp tool, didn't torque it up properly, or they'd become brittle. In removing one, because they're fiddly to remove, even with the right tool, they're a pain, to dislodge both and have that in front of their face with live voltage on. And when we're in this much needed, and it definitely is a thing we need to solve, the safe isolation on AC systems, it applies to the DC stuff as well. We need that wired into the systems. Isolation points should be in the fixed wiring. It's as simple as that for me. An isolation point that is in a piece of equipment that is connected to the electrical installation is not a place where you can make an effective isolation as a consumer and user or as an electrician. Because it's the same thing as you said. If there's a problem with the inverter, say the customer's seen some smoke coming out the back of it because an MC4 is melting away on there, they're going to want to go and be messing about with a DC isolator next to that or start pulling at the cables. They want to go and find every switch and isolator they can and start knocking them off while they're on the phone to you or me about it to get us to come out and have a look. That is what should be there, and I think it's a lazy argument to say the other, and unfortunately those people who are trying to sell this stuff at scale are using that to justify their approach in offering a cheaper solution through cutting that out. I think it's been used as a marketing tool where it affects diligent installation companies who want to try and do the right thing from losing work at the end of the day.
Yeah, I totally agree. I think just to share one story on what I've found before, I may have said this on the podcast, but I know I haven't said it recently, so new listeners won't have heard it. But I went to an install that we didn't do, but I went there because the inverter had stopped generating. And they knew that, like most customers know that, because they've submitted their feed-in tariff payments, and they said something must be wrong because it's the same reading as your last reading. So there must be something wrong over like a 3-month gap. So I went up there, and the inverter was on this real little bit of wall that was up in this loft, and it was quite a tight loft. And the first thing I noticed was that there was 4 MC4s into the bottom of the inverter, but there was no cables. And when I had a look and I got my torch out, I saw that these cables came from, for people listening, let's say that the inverter is on the left-hand side of the loft, but towards the middle of the loft. Well, the cables came from the back right of the loft, and there was not one clip on these cables at all. And they came all the way along the back of the loft to the left-hand side where the inverter was, and then forward towards the middle of the loft where the inverter was. And they were they'd been just no clipping at all, just been laid on top of the loft insulation and then gone into the bottom of the MC4s, obviously, and then plugged into the inverter, no DC isolator. And what had happened was there was boxes all around the central part of the loft because that's where the loft hatch was. So it became very obvious to me that what had been happening is the customer had been chucking boxes up into the loft and then taking them back out and then chucking more back in, Christmas trees, things like that. And because these cables weren't secured, a box must have caught the loop that had gone up towards the inverter, and as it had then put its weight on the box's weight, had then ripped the cable out of the bottom of the MC4. And that had happened to all 4 of these cables. How this house had not burnt down, because all these boxes were cardboard. There was cardboard boxes there was the building paper that you get in lofts. And I'm thinking, I've got to now sort this out, but there's no way for me to turn these panels off. And so then you're looking at it thinking, right, I've got to be really careful here because I can't leave it as it is, because it is literally, I'm not going to try and exaggerate the story to say that they were all a centimetre from each other. I can't remember how far away the cable ends were from each other, but they can't have been far from each other because they'd all come from the same place and they've likely been hit by the same box, probably the Christmas tree or something like that. And I'm looking at them thinking, right, I've got to try and sort this out. And the only way I could try and sort it out was to deal with one cable at a time and try and basically but make the end safe so that I could actually test the polarity of the 4 cables to find out which cable came from which part of the string, because there was 2 strings there, 4 cables. So I'm looking at thinking, right, I've got to know which one's positive and negative, and I've got to know which positive and negative go together. And that is a careful single one by one cable process that was painstaking and was a little bit nerve-wracking because you're up in a loft there as well, and it's dark and you're struggling to trying to work this out. So I basically had to make these safe and then properly clip them round. And the interesting thing was there was plenty of cable for me to clip it round neatly. So it wasn't even like they'd just done it like a bowstring from left to right because they were short on cable. It followed a route that you could have easily clipped it and then had an isolator next to it. So I clipped it all the way around and then put 2 DC isolators in. One of the ways I made it safe, and then a new set of cables out to the inverter, but clipped them back to the wall so that they couldn't be caught by any boxes. And obviously made the customer aware that, you need to be really careful with this. And to the customers, the customer doesn't know. They've got someone in to install this system because they don't know how to do it. And so you can't really blame the customer for doing it because they're just using their loft like we all use our lofts. But the incompetence of that installer, whoever they were, could have cost that home, just the house, it could have burnt that property down. I don't think that's an exaggeration in that scenario to quite easily see a route for those boxes to catch fire that are sat on top of the MC4, sat on top of the PV cables. And there wasn't really any smoke detection. There certainly wasn't anything up in the loft. So this property would only have known it was on fire. The customer would have only known this property was on fire when they started to get smoke inside the property. And by that point, that roof is gone. And it absolutely horrifies me nowadays when I'm going into these properties, doing our surveys for jobs that we're doing in my installation business, and properties don't have any smoke detection. And so that's why the PAS document for me, that's one of the biggest parts for me is lifting that smoke detection, not just because of the extra revenue you could get as an installation business to do it, but it's actually leaving that property safer than when you found it. And that's kind of the approach that we're taking now, because we can't beat people on price. We're going to install the equipment that we think will give the customer the best end product, but also make their homes safer, regardless of the solar and battery and EV system that we've probably been there to fit. We're leaving it safer so that if something happens, they're able to get their family out and maybe even react to what the problem is before it takes the whole house. Because I don't want to have that call where someone says that inverter you put up in the loft is has burnt my roof off. And yeah, that's something that that kind of keeps me up at night if I was to do that, I think.
Yeah. Just to interject today's show, we want to speak to you about another awesome product from Proteus, and that is the Type B RCBO that they've just brought out, Sam. We saw that in person on the podcast we did with Proteus, and again, it's helping us as installers, isn't it?
Oh, it's unbelievable how they have managed to engineer it to fit it all within a single module. I remember fitting the ones that are about 3 or 4 modules wide. How they've managed to engineer that into one module is an absolute... I don't know how they've done it, but it's fantastic that they have.
They have, and it's bi-directional as well. So again, thinking of us as installers for those PV and EV systems. And that is why we are so proud and honoured to be sponsored by Proteus on the Renewables podcast. But let's get back to the show. Like the fire service said, the loft space is like a tinderbox, to want of a better description, because it is exposed to those hot summer temperatures. It's dry. Everything in there is kind of chucked in all over the spot, and it's not that difficult to imagine it igniting, as you've just said there. And the maintenance piece is such an important thing that is not been done and often enough, and that what you come across if there was a regular inspection that needed to be taking place on solar PV systems, either through insurance companies saying your policies are invalid if you haven't got that, or some sort of regulated guidance like an EICR. It's hard in owner-occupied premises to make people do stuff. It really is. I understand that, but you'd maybe capture some of that before it becomes a problem. But as it is, this stuff's just left there until something does go wrong, like until someone chucks some boxes and sets fire to the loft, or a DC isolator fails through poor installation originally, lack of maintenance, whatever it may be. So I think that's one of the other aspects that needs to form part of the actual solution. Let's say we're reacting in a way that's saying remove components and stuff, but let's actually really look at it. If we do work as an industry and alongside insurers to try and encourage this maintenance package, that's surely going to improve safety and outcomes far more than mandating stop fitting DC isolators on stuff going forward. That would be something for me anyway, looking at it, that would be really effective. And the same can be said for sort of your AC systems too. We've seen it with the private rental sector when they started mandating EICRs for private rental landlords, and kind of the remedial works that took place through that program. We saw it in my business. So many homes where they were having like dangerous electrical faults that had been there for years put right, and they could be like live electrical terminals outside in a junction box where the lid's fallen off, and it's just been left there, and no one's done anything about it. I think we do need to really focus on that as an industry. And in fairness to NAPIT, and this isn't to pick one out over the other, they did put an article out that says that they support the use of DC isolators. So they have come out and said that. We have had a response to the PAS document from sort of the Wiring Regulations Committee, where they're implementing that in Amendment 4 as that drops in March, April next year, or certainly if it maintains on the path through the draft for public comment, it will. So that gives that kind of stuff a bit of teeth, a bit of something where it may bite and allow installers to push back into those places when it is all about price and other people are making the arguments around not been needing stuff, where there's a measure there for us to say, no, this is something that's been decided not just by us as an industry collective, because it's the safe way to go about things.
Yeah, I think that's right. And the more teeth that those sort of documents can have, the more, the harder it is for people to argue against it. It's we have to remember as installers our responsibility within the design part of this. And I think that's a part that can get overlooked to a degree. We're trying to make sure the panels are straight on the roof. We're trying to make sure things are securely fastened to the roof or the wall, or and that cables run in an attractive way, or think of inventive ways to hide cables and squeeze things into gaps that customers want them. But actually, we're also there to make sure that the design is safe, that we're able to maintain it, and not to devalue what we do on site as just screwing stuff to the wall and just plugging stuff in as quick a manner as possible. We are there as electricians, and it's the same for plumbing heating engineers. They've got to make sure that that their connections are correct, their pipe sizes are right, the flow rates are right, all these other sorts of things. It's no different for us as electricians, speaking about our trademark. And that's a responsibility that I think does get overlooked in the heat of the battle of trying to run a business and do installations. It's like looking back at what are you actually being employed to do? Yes, you've been employed to fit batteries to a wall, to fit solar panels to a roof, but you are providing that customer with a certificate of compliance to the latest regulations. And if you haven't actually taken that on board when designing the system, then effectively you can be signing your own, court case by doing it. And I think, I sometimes feel it when I'm doing a test certificate or reviewing one that the guys have done or all these other sorts of things. It's kind of thinking, right, this, if anything goes wrong, this is my piece of paper to go, we did this correct. This is our proof. So it's there, your test certificates and your commissioning documents and your photos and everything like that are there to prove that you've done the job correctly. I know for a fact that over the course of my career over the next, if I last this long, 20 years, 30 years, it's going to be, I'm going to have an inverter fail. There's going to be, an isolator that fails, a generation meter that fails. Hopefully we can get rid of them, but a generation meter that fails. There's going to be things that fail that no matter how well I could have installed them, they will fail. And I need to prove that I've done everything competently to the letter of the law or letter of the guidance, the standards, so that I can lean on those and go, look, I'm really sorry that this has caused some damage. You could cause some damage. It's electrical piece of equipment that can overheat, that can spark. But this, even though it's mortifying, this is the risk that you take as a consumer, having more electrical components in your property. But from my side, this is my certificate to say that everything has been done correctly. And leaning on that, you need to be able to lean on your design as well, because you are effectively signing that you've done the design correctly, but you've also signed that you've tested things correctly and that you've erected things correctly. And so you need to be confident that you're doing that. And even when the rules seem a little hazy, or the standards or the guides, whatever you want to call them, seem a little bit hazy, you're not sure which side of it you should fall on, like with the DC isolators, or like with the DC surge protection that we'll talk about soon. You've got to make your technical judgment as an installer, as a designer, as a business owner, as to what is going to be best for that end user and that installation. And I think when you start thinking about things like that, like I said right at the start of this podcast, it is very hard to argue against fitting things like the DC isolators.
Yeah, the design side is such a critical element, and it does get missed in the hustle and bustle of rinse and repeat systems week to week. It's really easy to fall into those. Well, it's this size cable, it's that many panels, it's this size inverter, and stuff can catch you out. Like volt drop can get you if you've not got your AC and DC calculations right. You might have undersized an isolator size somewhere. It's really easy if you don't go through that process carefully and evidence it, as you've said. That is it's not to catch you out, it's your way of proving that you've done every best effort to do a good job. So it's a really, really good point. And I think that is one that lots of us, if we're honest, forget now and then, whether we like it or not. And at large scale, where these companies are doing it at volume, it's probably not getting done at all. Is the truth. It's really hard
that, like we said on other podcasts, the one we've just recorded before this, with where I'm trying to get my business to, doing 2 jobs per week, and me kind of thinking that that's probably where I'll sit for quite a while after we get to that point, as long as there's the demand in the market still. Mainly because I don't feel like at the minute, where I am at the minute in my business, I don't feel like I can really keep a handle on the quality if I go more than that. And again, like we've mentioned before, that for me, the quality side of it, for me, is the most important thing. It's the only thing that I can compete on, because I can't compete on price, because some of the costings out there, some of the are just unbelievably cheap, and so I have to sit on my quality. And so going any more than that, it dilutes the ability to look over the quality. And these big solar installation companies, there'll be some of the installs that they're doing that will be absolutely unbelievably good, and hopefully the majority of them are like that. But I do worry that you get to the point where you have so many jobs on You have maybe new subcontractors coming in, if that's your business model, that maybe aren't as trained as what you thought they were. You might have all the right intentions. I do genuinely believe that most of these companies have the right intentions to do really good installs and everything, but the scale of the machine can potentially outrun them in being able to check that quality. And again, I'm only making assumptions here, so I don't have any evidence to say that's happening, apart from what I see out there when we go and do maintenance on things and have a look in. And some of the same names do come up, but I've got no other evidence than that really that this is happening. But I know through trying to scale my business up how hard that is, and that will be the same challenge for any business that's trying to scale up something as high value and something as labour intensive as doing a solar battery and EV charge job.
Yeah, 100%. And we had a price come back the other day. I think the customer had a quote for $8,000, and when I'd worked it out, the parts was going to be $8,500 for me. So it's like, I don't know how you're making those math, but somebody clearly is somewhere. I know, like you say, I'm sure lots of it is done with good intentions, but maintaining that quality when you are at such fine margins and volume, it's really, really hard. This isn't just box shifting at the end of the day. It's screwing stuff to people's roofs and taking their houses apart, and mistakes are very, very easy to happen, and then you have the problems that come about. And I guess it's enforcing those standards. I guess that's really what I'm trying to say through the course of this podcast, that if we've got a baselining standard that the manufacturers agreed on, that the installers are agreed on, that the industry of things have agreed on, we know that's where it needs to be. It's then a case of just policing to that, and we can utilise like AI through MCS and pictures and things that they can maybe start asking for and monitoring a little bit more often, rather than an assessment they come out to once a year, or a sneaky assessment they did on you last year or whenever it was, where they can look at most projects utilising software and like a third set of eyes on stuff in the background, where if you've got to submit 5 pictures from your install, like the roof with its hooks on maybe is a good one, and with the panels on top after that, and then the inverter pre its connections and post connections. I don't know, just something along those lines where some clever AI bots can have a little look and flag stuff up where they think actually a human might want to look at this because it looks a bit ropey. Something along those lines where we can get a bit of foresight into what's going on in the marketplace and raise that bar. One of the other kind of areas of contention, and you referenced it a few minutes ago, is around the DC SPDs. And this is one where I've been on a bit of a journey with some manufacturers actually saying fitting the DC SPDs external to the kit can lead to issues when there is a DC surge, and you're just like, what is the actual science and rhyme and reason? I'm just an electrician. We just want to know what is the right thing to do in these situations, and it is so difficult. We went through a process of fitting DC SPDs on everything, then we stopped for a bit because of that advice, and now we're back doing it again. It's so easy to get befuddled by some of this stuff.
It is. It's an absolute chew. We've been on a bit of a journey with the type of equipment that we've been fitting over the course of the few years, and when the whole AC surge protection side of things came into the regs, and through having a look at that and some of the other guidance out there, effectively the guidance was in that document that if you require it AC surge protection, you also require DC surge protection. And so we were like, right, okay, that's fine. We'll start fitting it. And then when you start looking at the documents, you go, oh, some of this equipment's already got this in. Oh, fantastic, that's great. And then you hear and see that actually that might not actually be a surge protection device that meets the right standard. And you think, right, okay, what a nightmare this is to try and navigate. And because, some of this stuff is not cheap. Some of these surge protection devices, depending on which one you're using and what type you have to have, they're not cheap. And I know for a fact that us including some of those could close the gap between us and some of these other jobs that we've lost through price. It's not going to be removing thousands off our price, but it's quite a high value piece of equipment that if we don't need, and we've maybe got 3 strings, which is quite common nowadays, that's 3 lots of this high value piece of equipment, plus the labour time to fit it, plus the connectors that you need to allow the cables to loop in and out, and all this other sort of stuff. And before you know it, you've added easily a couple of £100 onto your proposal just for that surge protection. And so finding out whether or not that surge protection that is within the device is actually compliant is really important for us all being able to bat on the same field, really. It reminds me a lot about the whole My Energy Zappy RCD debacle, where, suddenly the one that's inside the device wasn't, because it was electronic and it wasn't the right BS number on it, then suddenly we have to fit RCDs up front, but then we were all told that it has RCD protection built in, so we don't need to fit it. And you're like, well, which one is it? Surely we should be able to work out if we do need it or we don't need it. And I think we're kind of entering that stage now with the surge protection side of things. The DC isolator for me, and for most people I speak to, is a no-brainer. The DC surge protection thing is a lot more muddy because of what we're told these pieces of equipment have within them.
Yeah, absolutely. And it's so hard to figure out, especially when some manufacturers are saying you can actually prevent their internal protection measures from kicking in and doing other stuff if you have got a DC SPD. It's beyond our pay grade, I think, to figure that out. And that's where wiring standards and product standards overlap. I do think BS 7671 has become too involved in defining elements of product standards, and now they've started doing it, and they started doing it in a way with those RCD devices in EV charge points and SPDs as well in AC systems, that they've begun doing it. They've kind of got to keep doing it, and that's one of the reasons that book is growing so much at the minute, and it is receiving the updates it's getting. It's because they are trying to cover off elements of product standards, I think, that maybe aren't there to begin with or aren't set out in the way that they think they need to be. So it's from a genuine intent of plugging that gap. But in doing so, it's not really giving us an answer in terms of how we should be doing things. I think if you are going to go through that process, you need to actually come to the conclusion that, yes, you need to fit DC or AC SPDs, or you need to fit whatever product and device it is, rather than end up with this interpretation phase that we could get stuck in, and then it's all kind of on us as installers. And the DC SPDs, it's like, what are we protecting from with that? Because the assumption is it's lightning strikes, and a lot of the time it's not. It's like atmospheric conditions and stuff. And we had one where it had gone. I don't know if it was due to an actual event or it's just gone, broken. I don't know what it would be. And in the world of the AC SPDs, we've had a few. So they do seem to serve a function, because they're going to the different coloured flags and need to be replaced. And that's my other complaint with this stuff, is that when it's operated, most of the time no one even knows, because nothing trips off, and it can be left there then for years without it even in place anyway, by nature of it operating once.
Yeah, and that's where, there is an argument for allowing the ones within the pieces of equipment to be your surge protection, because that, you would assume that it's got some sort of, status symbol on it, where it'll actually flash up that there's been a surge, and that the cartridge, or because that's the other thing, where is the actual surge protection in some of this, and that something has actually happened within that, and that brings us right the way back to the maintenance side of things as well. Looking at these sort of installations, the more pieces of equipment we install to meet the standards, the more we need to make sure that those pieces of equipment are being monitored, because I've had one DC surge protection go. I think that was because it was a faulty cartridge more than anything, but still, that cartridge had failed. Whether or not it was failed doing its job or not is it doesn't really matter. But that cartridge had failed, so that's left that piece of installation open to something happening through a genuine DC surge, which might not happen for another 10 years from that cartridge either failing or being operated. And so suddenly, if we're going, right, we have to fit DC surge protection on every single string, we've come to that consensus, then we kind of have to attach some sort of maintenance to that. Because if that cartridge is there to serve a purpose for safety, then we need to be able to make sure that cartridge is in an operational state for as long as possible. Otherwise, what's the point of fitting it? It's like the whole, quarterly test your RCD. I've never met one customer. Actually, I've met one. That's a lie. I have met one that did it.
That was a keen one.
Yeah, very keen. I'm happy to admit, Mark, I don't even do that in my own house. I don't.
Yeah, I can't remember when I've hit the test button.
Exactly. I just don't do it. And so, whilst that's naughty of me being a person in the know of how important those pieces of equipment are, the reality is people just don't do it. I get my boiler serviced every year, and there's a gas test that's done on that boiler. But these electrical installations that are being fitted around the country, regardless of them being solar or battery or not, the more things we fit in our properties, the more important the maintenance becomes, because there's more that the regulations are telling us that could go wrong. So we need to be making sure that these pieces of equipment are working for as long as possible.
Yeah, I think that's such a strong argument, and we kind of have this well-intended, I think, effort of industry to make changes to get things to improve, but sometimes they can end up in these rabbit holes where they're not really doing it, and maybe the DC isolators is a good reflection of that, where that report's come out and it's like, well, let's just get rid of that then, because that's the easy win, isn't it? But really, if they want to affect that change, it is looking more towards stuff around maintenance. And I would say we've said this before, that with the solar side especially, it's the bird guard. It's such easy wins, a lot of this stuff. Bird guard, smoke detection around stuff, so people are alerted if there is problems. And really through the conversations with you, because it was something that I knew should be happening, but maintenance wasn't something that I was actively considering. Really, it's been one of those, but it definitely is. And that's from having the chats with you and been on that call with the fire service earlier on in the week. I think there's some things that as an industry of things, we should really be focused in on, because they're the ones who can get those changes made where it actually starts to happen. They can pressure government and insurers to look at this stuff and start trying to mandate it and encourage consumers to do it. And then we get safer systems, better outcomes, and less problems. I think that's maybe where we need to look at solving the problems rather than just reacting to them.
Yeah, and this might be a terrible analogy, but when you have places like Drax, and even some of the when we start to roll out these small nuclear reactors and all this sort of stuff, they're a generating set. They're a generating set that's there. Would you expect them not to ever be maintained?
Who knows what they're doing, mate?
Yeah, well, who knows? But in my mind, they will have maintenance teams going around making sure everything's okay. Now, I know the scale is completely different, but we are generating energy. We are storing energy. And whilst the scale is different and the risk or the effects of a failure are in a different level, the risks are still there. They're just in different proportion. Having a stored amount of energy sat in your garage next to your EV or your diesel vehicle or whatever, where your gas boiler's on the other side of the wall, all those sorts of things, we need to be more open to the risks of these things. And that's where the PAS document comes in, and that's one of the reasons why I've taken it on so strongly, because I do think that there are parts that I don't agree with, like some of the window distances, I think are just a little rubbish. But the general idea of the PAS document and the idea that the industry did get slightly ahead of some of these things happening, I think is really good. But we didn't receive it very well. Installers didn't really want it to come out. But then what I find is that what we like to complain about is regulation not keeping pace. But this is kind of almost felt like their attempt to keep pace with it. But then there was just arguments around it not being, it's not regulation, so we don't need to do it. It's like technical guidance is out there. Read it, digest it, and if you're not going to go ahead with it, then you better have a good reason why you're not going to do it. And I think that's the same thing around the DC surge and the DC isolators, is that if you're not going to do it, have a good argument ready for why you're not and be able to prove why you're not. Because it can't be about cost, because that is not an argument for safety. That's an argument for your business. I think the argument around DC surge protection is one that can be quite adequately made at the minute, because we need some more clarity on if these surge protection devices are actually compliant that are in these pieces of equipment. And if they're not, then we need that to be made clear, because I'm not clear on it at the minute. I'd love to I think we're going to reach out to some surge protection people to try and get them in to try and get some clarity on it. But yeah, I'm not 100% clear on it at the minute, and because I've got other stuff to do. I can't be an expert in solar, battery, EV, surge protection, arc fault, all this other sort of stuff. We rely on each other to enlighten each other, and we rely on people that do have that little niche to enlighten us and to work with people that are creating these documents to actually go and try and give us as clear guidance as possible. And I think the surge protection for me is the one that's we're a bit unsure about it. We need it, but are the ones that are built into the devices actually adequate or not?
Yeah, that's such a good point you've made about us complaining at the industry of things when they do come forward with ideas and stuff, that we moan at them for not doing anything, and then we moan at them for doing something that we maybe slightly disagree with elements of. And we do need to be careful of that as electricians, to not put that kind of effort off, because I think that's something that is really, really important. And I've been mindful of that myself around training, because there's been moves to sort out standardisation across training where I think there's been some massive mistakes made, but it's trying not to strongly message against all that for putting up the effort of actually doing it. It's trying to work with people, I suppose, is what I'm trying to say. So hopefully the industry of things will work with installers out there through the committees and groups that exist. Like we were on that call with the fire service and stuff. There is groups for MCS as well, and there's groups with the CPS providers and the IET where we can have a voice and filter stuff in. So if we're really passionate about that kind of stuff, it's up to us to do that and have those conversations. So I think that's where we are, in my views, on closing this one out. I think there is some changes that are needed to be made around the quality of installs that are going on, but for me it doesn't involve removing DC isolators. That's my closing statement on it. Fit your DC isolators.
Yeah, I echo that, and hopefully we can help bring some clarity around other people in the industry around the surge protection side of things, and just allow people to be doing things correctly. And I include myself in that. I want to make sure me and my teams are doing things correctly, and hopefully this podcast can be one of the many avenues that gets that message out there. Because many people that will be listening to this will be the type of installers that want to do things right, and hopefully we can bring some value to that by finding that out and sharing stories like we've shared today. When people are thinking maybe of just skipping clipping the cable, or skipping putting the isolators in, or all these other little things, and just almost like just reality checking that a little bit and go, right, no, I am responsible for this system, I'm responsible for the design, I'm responsible for the maintenance, I'm responsible for all this sort of stuff. Do I really want to make this harder for myself? And so that'll be my closing remarks, and that's a journey I go on every time as well. When I'm pressured on price, I'm thinking, well, maybe I should just get rid of the DC isolators. But then common sense takes over, and I go, no, that's a really important part. And so we all go on those journeys. No one is kind of up there on a pedestal. We all go through those challenges. So yeah, that's my closing remarks. So I'll take us out, and look forward to speaking to you very soon, Matt. But thanks very much for watching and listening to another episode of the Renewables podcast. Thanks again. It really means a lot to us that you keep tuning in. And like Mark said, if you haven't already subscribed to the channel, where you get automatically shown a new episode that comes out, or even if you want to go one step further and support the podcast with a subscription, then we've set up a really small subscription that really helps us with the running of the podcast alongside our day jobs. That is available on Spotify, and no matter where you're watching, we really appreciate your support. We'll see you on the next episode, and have a great Christmas.
You can go skiing now, mate.
Yeah, that's it.
You're off. You're done.